Hi, math lovers. Welcome to Notes number 10. I'm just going to do a brief overview with you of some of the concepts in this lesson on factoring. We've already spent some time in class working on our factoring. Remember when I said our textbook kind of throws it all together? So I did some slow review the first 3 days of school when we had those worksheets. Now we're getting it right back out. We're getting right going. We're going to get ready to it. So let's talk about factoring. The first step of factoring is always to pull out the greatest common factor. And I know you're super familiar with that because this is where factoring starts. We're going to find the greatest common factor. We're going to pull that out. So if you think about when you do this, it's like you're making the multiplication problem. Like you're the teacher. You're the person that's creating the problem, the product. So you look to see what is in common with both of those terms. What's in common with 9y to the 5th and y to the 2nd? Well, you could pull out a y squared out of both of those terms, and then you finish the problem. Well, you ask yourself, hey, if I were to set it up, and and that's really what I do. When I set the problems up, I think about it as what should go in those blanks? What fills in those blanks? What's the term that should be there? Y squared times what number should be not to give me 9y to the 5th? So I fill it in that way. Similarly, looking at letter B here, I look at my terms. What's in common with all three of them? There's a 2t in common with all of them, okay? So, I pull that out and then I take it from step by step at step. I think about what should belong in those blanks. 2t times what is going to give me my term? 2t times the second term times the third term. And, it's a great way to think about doing the problem. And then we get to question C. Okay. If I were to change this question, let me change it and just say to you, hey, 14x to the third minus 28x to the second minus 7x. What would you say is the greatest common factor? Here, let me isolate that so you can really just focus on that. What would you say the common factor here is? I would just say it's a 7x. A 7x is going to go into each term. So 2x squared minus 4x minus 1. Wouldn't you? But what if x is not what we're doing? Instead, I'm factoring out a 7m squared. Okay. And so this is really what I'm thinking about is would be my x. I'm factoring this out. To be honest with you, I think this one is quite an advanced question. Might take you a couple tries to think about getting your head wrapped around it. But I kind of love that how it looks so monstrous, but it's really not. Watch what happens. So once I get the squared here, right? Let me undo this. So you need to see the problem. So I have m plus 1 in both of them. So what would happen if I take just this and I start to simplify? Let's figure out what I have. So I'm going to go ahead and FOIL these two terms together. I'm going to distribute the -4 here. Once I FOIL these two, I'm going to distribute the 2. So I have this here. And I come on down to this whole, look at that whole equation. I've got 4m and -4m, they're going to fall out. And then I have all these constant terms I can go ahead and add together. Look at how beautiful that problem is. Look at how it all just fell apart. Oh, just such a fun problem. Okay. I would think that this one is more advanced right now than maybe we're ready for, but eventually we'll be building up to problems like that. Okay. The last thing I want to show you today is factor by grouping. So factor by grouping is when you can take, hey, these two go together and these two go together. Let's see if we factor something out here and factor something out here. So we did some of this to start the school year off. I always like to go in the order that it's given to me. So notice here that I have an m in both first terms and I have a 3 in the second two terms. What's nice is I can pull out the terms. I pull out an m from the first set and I pull out a 3 from the second set. And I'm left with this beautiful, beautiful product, okay? This one's not in the order that's going to help me. I noticed that these two, there's nothing in common, and there's nothing in common here. So what I'm going to do instead is I start by reordering the whole problem. And how nice it is for me that this whole thing is going to get reordered. So let's try putting the 2 out front. Okay, we got the 2 out front. And then I'm going to left with y squared minus z. And over here, if I factor out the a, that's not going to be y squared minus z. It's going to be z minus y squared. Huh. What if I try reordering that again? What if I take these two and I kind of switch them around and I pull out a negative a? Oh, that's going to be nice for me, isn't it? So here in this term, I pulled out the negative a, and now I have, using a little bit of trickiness, now I have something that's the same. Do you see why that first 3 days of school I spent doing the factoring? Because our textbook really, really kicks it up a notch. You know, this is quite a fun, elaborate question. Okay. Take a look at C here. Just so I don't scare you. This would have been what I put on the worksheets. Okay. So looking to see what you have in common with these first two and the second two. The first two, I have a 2x squared. The second two, I have a negative 1. All right, so I pull those out and notice that I have the same set of parentheses. I could pull them out of both, and I'm left here, okay? That's enough to end for today. The last thing I want to show you is this beautiful little graphic, which I showed you when we first started school, those first 3 days. When we go in this direction, we are multiplying, right? We have a multiplication problem, and this is going to be our product. When we go in the opposite direction, we are factoring, okay? So factoring and multiplying are opposite operations. Have fun with your problem set.